Hi, good afternoon, good morning, wherever you may be. This is Penelope Weinberger. I'm the Transportation Data Program Manager from AASHTO, and I want to welcome you to the Geospatial Online Transportation Users Group, or GOTUG's 10th webinar. We're going to wait another couple minutes before we actually get launched, or a minute or two anyway, mostly because we're still waiting for one of our presenters. So in the meantime, I hope you guys pay a lot of attention, you folks, and you think of lots and lots of questions for Caitlin Marousis, who's giving our first presentation, our first technical presentation today, so that we can, make sure that we have time to get to the other presentation when the other presenter arrives. So it's just 1 minute after 1 o'clock Eastern time. This webinar is being recorded, just so you know, so that we can post it online later, and we can get people who are not attending it live today to be able to see it in the future. So I'm just going to start at about 1:03 with this presentation, and then we'll do our two technical presentations, and we'll field your questions. In order to ask a question in this webinar, the easiest thing to do is to type it into the question box or the chat box you'll see on your dashboard panel down at the bottom. There's a little expandable button that says question. So just go ahead and type it in there, and I'll read it out for our presenters to answer, or if it's addressed to me, for me to answer. All right, it's 1:03 p.m., our precise and official start time, so I think I'm going to get started. As I said a moment ago, I'm Penelope Weinberger. I'm the Transportation Data Program Manager for AASHTO, and I'm the AASHTO staff person to GOTUG, the Geospatial Online Transportation Users Group. Today, June 6, 2018, is our 10th webinar, and I'm just going to go through and tell you what we've got going on. Our agenda today, welcome and overview, which is what we're doing now. We have two technical presentations today. One is on prioritizing barrier replacement with GIS by Caitlin Marousis, who's the Operations GIS Manager of the Utah DOT. And then she'll give her presentation, and then we'll have a question and answer. And then after that, we're going to have an environmental impact assessment streamlining with GIS presented by Ryan Arthur of North Carolina DOT, and that will be followed by a question and answer for Ryan, and any questions for Caitlin that you will have thought of by then. So first, I want to give a brief overview on GOTUG's history and future. The key people for GOTUG are Becky Helm of Utah DOT, although I know she's trying to get away from us, so we may be putting out a call soon for our next co-chair, and Jeremy Aycock of the North Carolina DOT, and as I said, I'm the AASHTO liaison, Penelope Weinberger. GOTUG is the Geospatial Online Transportation Users Group. It began as part of the AASHTO Innovation Initiative, which was initiated by Utah DOT. The AASHTO Innovation Initiative is a working group under the Standing Committee on Planning, or it was the Subcommittee on Data. But GOTUG is now part of the Committee on Data Management and Analytics, because AASHTO has undergone a reorganization, and for the first time in 50 years, we have reorganized all of our committees, or a lot of our committee structure, and we have created some new committees, and one of them was the Committee on Data Management and Analytics, and GOTUG and GIST, of which many of you are probably familiar, fell under the Committee on Data. So this work group will provide ongoing support and development of transportation agency capabilities regarding comprehensive GIS-based online collaboration platforms. The GOTUG Steering Committee is Becky Helm, Eric Abrams, Jeremy Aycock, Andrew Wimsatt, and Mark Sarmiento for the Federal Highway Administration. So why was GOTUG started? GOTUG was started to maintain the momentum that started with UPlan, the AASHTO Innovation Initiatives, and it was started to marry business needs with innovative web-based geospatial solutions. And of course, if you've been to a GOTUG webinar before, you've seen this presentation. We just tweak it a tiny little bit as we go. And of course, all these presentations will be available for download together with the webinar when it is put up after having been recorded and finished. So here are some technical resource information for GOTUG. One thing that's new, or it was new at our last webinar, so now it's 3, maybe moving on to 6 months old, is that we have a new distribution list, which is much easier to join. And I'm very delighted to say that shooting up from its original about 40 people that used to be on it when it was difficult to get on this distribution list, since you can self-enroll, it contains 177 distinct addresses. So that's really good for us. And it also means that more people see more webinars and we can get more information out to the GIS online community more easily. So our next GOTUG activities are going to be the next 2 webinars after this one, September 5th and one on December 5th. And the one on September 5th is going to be on HTML5 mapping. One on December 5th is going to be on capability maturity for GIS. I'm muting you right now, Ryan, because it sounds like you have the phone and the speaker on, maybe, which is what that echo was about. So we're going to turn you back on when it's time for you to give your presentation. Hopefully we can resolve all those feedback issues. So those are going to be the next activities of GIS. Right now, I'd like to introduce Caitlin Marousas, the Operations GIS Manager for Utah DOT, with a presentation on prioritizing barrier replacement with GIS. Caitlin is the Operations GIS Manager in the Project Development Division at Utah DOT. In this role, she supports the Maintenance, Traffic and Safety, Traffic Operations Center, Equipment, Motor Carriers, Risk Management, and Aeronautics divisions. Before working with Utah, she spent 10 years in the private sector environmental industry. She earned her bachelor's degree in environmental science from Willamette University and her master's degree in GIS from the University of Utah. I'm just going to turn it right over to you, Caitlin. And if you have any questions in the audience as we go along, please type them into the question bar, and we will read them out, and Caitlin will be able to answer them. Take it away, it's all you.
Okay, can you guys hear me and see my screen?
I can hear you, and I see beautiful Utah.
Excellent. That's actually northern Arizona. That was the Grand Canyon a couple weeks ago, so I'd like to claim it as Utah, but it's not.
Oh, maybe you should show it to me again, and I'll see if I can recognize it.
Oh, right. We'll grab that at the end of the presentation. Okay, thanks for the introduction, Penelope. As she stated, I'm the Operations GIS Manager for Utah DOT, and I'll be talking to you guys today about some barrier prioritization work that I helped our Traffic and Safety Division with. So just to kind of go over the basic outline of what I'll cover today, we're going to start, I'm going to try to set some context of the importance of our barrier and guardrail assets to UDOT, kind of go over what the problem statement was that the Traffic and Safety Division came to me asking for help with. That looks at both from an asset management perspective and a financial funding perspective. And then kind of how I leveraged some different GIS tools to help the traffic and safety folks identify, score, and prioritize barrier by risk and exposure. So just to set the context, UDOT has 3 strategic goals. One is 0 crashes, injuries, and fatalities. The second is to preserve infrastructure, and the third is to optimize mobility. Obviously, barrier and guardrail assets play a very significant role in that first one. You know, obviously the idea there is to reduce severe and fatal crashes, but it's also a very important component of the second one as well. UDOT has this saying that good roads cost less, but preserving infrastructure really applies to any of our physical assets, not just the actual roadway surface and our pavement. And so these are kind of play hand in hand. Obviously, keeping our barrier and guardrail assets you know, up to certain safety standards and in good working condition is certainly going to help us work towards that first goal. And so just to give you kind of a summary of the barrier and guardrail asset picture in the state of Utah, we've got about $440 to $450 million worth of barrier and guardrail assets. That's about 1,500 miles statewide. And a quick summary for the decade between 2006 and 2016, We estimate that our barriers were hit by nearly 40,000 vehicles. That's estimated to have prevented 177 fatalities and 829 serious injury crashes. Obviously, fatality counts vary widely from state to state, so just for a little context there, that's for fatality reduction, that's about a 7 to 8% reduction, so very significant there. We also estimate that there were $3.63 billion reduction in crash costs. And obviously with that, the idea with barrier and guardrail is that it reduces your severe injuries and fatal crashes, but it does increase your minor crashes where you've got vehicle damage from hitting that guardrail, but hopefully you've saved someone's life from them not entering oncoming traffic or, going off a steep embankment or whatever. We estimate that our barrier system has an annual benefit that's about 75% of its replacement cost. So again, this slide is just kind of intended to give you a real quick snapshot to set the context of its overall importance to our statewide system. So how do we inventory our barrier and guardrail assets? We've been working with Manly to do LiDAR data collections. We just did the most recent one this last fall in September of 2017. That was, I believe, our third or fourth LiDAR collection with Manly. So we're slowly building up a kind of a historical picture. Specifically from that September 2017 collection, we estimate that we had 10,927 assets on state routes. So again, this Manly collection is only done on state routes. It's not done on local or county routes. So that's just the statewide picture for UDOT routes. The information that we collected during this run was obviously spatial location, plus attributes that included route and milepost to tie it to our LRS, the barrier type, the high-end treatment, the low-end treatment, post type, height, and offset from the roadway. So that's just a picture there of one of Manly's collection vehicles. So again, that was done in September 2017. We've just recently finished kind of processing and calibrating all of that. It's one of the data sets that's available for download on our open data portal, and we've got maps in our AGOL portal, which is UPlan. So one of the issues that traffic and safety came to me kind of trying to wrap their arms around was that we have some known issues with some outdated barrier designs. One of those is this Texas turndown that you see there in the picture. It's a pretest asset which predates 1960. So some of the issues with those barriers is that, especially with the larger, heavier, taller, modern vehicles, they're too low. And so they can cause rollovers. If a vehicle strikes it, it can actually flip the vehicle over. The other issue, as you can see how that end kind of tapers down into the ground surface there, a vehicle can actually run up on that and then flip over. In 1994, FHWA did mandate that we come up with a specific removal plan to address this particular barrier type. In 1996, our State Transportation Commission allocated a specified dollar amount per year, about $300,000, to address this issue. Just this year, we have removed, or this last year, we did remove the last Texas turndown from our national highway system routes. We estimate that we still have approximately $10 million worth of these barrier types on non-NHS highways. So again, that was kind of one of the things that we tried to pull from this Manly collection, is understanding the spatial distribution of where these particular problematic outdated designs were in the state of Utah. Another known issue is with these concrete jersey barriers, with in particular a specific design that has cable loops. These were installed from the 1960s to the mid-1990s. These have the same issue. They can be too low for modern vehicles. The other issue is that each of these separate concrete sections are held together. There's a cable loop that sticks out, and then a metal pin that drops in between them. And that's intended to hold them together, keep them acting as a cohesive unit. The issue with those cable loops is that there's so much surface area with those cables that they have rusted and deteriorated. And the issue there is then, instead of functioning as they're intended as one continuous barrier, a vehicle strike can actually displace a single piece of barrier and the vehicle can pass through, or it'll displace it and strike the next barrier as an end blunt object. And the issue here is that we have two different barrier types. We have the 12.5 foot and the 20 foot. We know that all of the 12.5 foot is this older, outdated cable loop design, but with some of the 20-foot Jersey barrier that was identified in the Manley collection, some of it is up to standard and some of it is not. And the way the data was collected, there was no way to differentiate that in the actual LiDAR collection between those two types. The other issue is that we've done some mitigation by installing that steel plate that you can see in the right-hand photo. The issue with those is that they have not been crash tested, so we don't really know how they would perform in the event of a crash. So with that kind of picture of what our guardrail and barrier assets are worth, given their intended lifespan, we are behind, given the dollar amount that we're currently allocating to barrier replacement. We've ran some estimates. At the current funding picture, we would be replacing outdated barrier well into the year 2080 or so. So that kind of just shows that at the current rate, we're not replacing that outdated and unsafe barrier fast enough. Obviously, they'll get replaced quicker if they are struck by a vehicle and there's damage to the point that they need to be replaced. But if that doesn't happen, they are lingering on the roadway just because of that funding gap. So this project was kind of intended to help traffic and safety communicate that message and start to prioritize and come up with a way to more quickly replace some of that barrier. So they came to me and asked basically, how can GIS help with this issue? They wanted to know where the problematic barriers were located in the state, maybe come up with a way to identify risk and exposure of those barriers, and then therefore come up with a way to start prioritizing higher need areas and communicate that throughout the department. They also wanted to understand more specifically what the Jersey barrier situation was. Again, like I said, the 12.5 foot we knew was not up to standard, but there was an unknown quantity of that 20-foot Jersey barrier that we weren't sure about. And then they also wanted to come up with a way to visually present this to department leadership. So the first tool I put together, again, because Manley didn't distinguish in their collection between the older 20-foot Jersey barrier design and the newer design, instead of sending traffic and safety personnel out on field visits to try to start to quantify that, I created a web map where traffic and safety staff could sit at their desks and do a visual inspection of this Jersey barrier. Part of the Manley collection was also this road view imagery, which was collected again on all of the state routes. And so essentially, I set up a web map to help eliminate hundreds of hours of field work, and also, you know, from a safety perspective, not having folks out on the roadway doing inspections, allowing them to just sit at their desk and do it. So these are screenshots here in case the live demo doesn't work. You never know, but we'll give it a shot. Are you guys seeing a web browser open up?
Yes, ma'am.
All right. So as you can see here, it does prompt for a login. I set this up as a service that was secured to our servers, so just anybody stumbling around on the internet couldn't get into here and start editing our data. And so again, this was set up with credentials for a specific set of traffic and safety personnel. So what you're seeing here is the green dots are just our milepost layer on our state routes. The linear assets there, that's the actual Manley data. So that's delineating where they've identified that we have barrier. And as you see here, we can come in and click on a particular barrier, and that's just going to list all of the different attributes that were collected during that Manley run. So you've got route, travel direction, since this is a divided highway. We've got mileposts, barrier types. You can see here there's that Jersey barrier 12.5. lists the high and low end treatment, collection date. And then what I basically set up here was just, you click this road view logo at the bottom of the pop-up. And you can see here in the URL, it's essentially just a dynamic. It pulls in the route, you can see there, the direction, the milepost value, and it's looking at our most recent collection from 2017. And so it's essentially just dropping you into this viewer at that particular location on the roadway. And the intention here was that the traffic and safety staff, again, sitting at their desk, could then come in here, and as you see on the right side of the image, just below that brown sign, we've got our older Jersey barrier. And so they can visually inspect, essentially what they're looking for is these are just clean, flat faces there on the front of the barrier. The newer designs have two kind of divots, what they use to move the barrier during the installation. And so that's visually how you can tell without needing to actually get up close and look in between there to investigate the cable loop. You can tell that this is indeed the older, outdated design. And so essentially what they could do is just click through the barrier, click on that road view link, it would drop them down, and then using this photography, they can just easily identify whether that particular barrier section is up to standard or not up to standard. And so again, we've established here, based on the appearance of the barrier, it's the older, outdated design. And so what they do is come back in here. This is an editable feature service. So click the edit, and then it's just this domained drop down of basically meet standard, does not meet standard. There are certain runs of Jersey barrier that may partially meet standard. So if they did select this, then we ask them to attempt to quantify, just give an estimate, 50%, 60%, whatever does meet standard. Plated, again, is that steel plate that I showed on one of the earlier slides. Some of these were identified as Jersey barrier, but they're actually parapet, so that would possibly be replaced or updated under our bridge maintenance program. We've got cast in place and then other. And so again, what this does, if they would enter other, we can then have our barrier specialist come back and review just those. He could come into the web map, filter on that particular attribute. And so essentially, what we've done is just created a way to add additional granularity. The way the Manley data was collected didn't provide us with enough detail to start to do that kind of analysis and wrap our heads around how the Jersey barrier was distributed. So that's basically just a real simple web map, again, with an editable feature service. It's secured to a particular group of traffic and safety employees who are allowed to edit the map. So again, they estimate, they did probably, I think, about 40 hours of desk work to do a full statewide inspection, which again would have been weeks of field work. Utah's a large state, would have been a lot of driving around and a lot of potential risk standing on the side of the road doing those inspections. So we should be back to the PowerPoint view. That's, again, the first tool I built for them. And then the next question was to try to get at the idea of risk and exposure. So, okay, now we know where these outdated and substandard barrier designs are located. How can we start to prioritize, given the limited funding picture, where funding obviously doesn't meet the full need, how can we start to identify the hotspot areas where we really need to focus and prioritize some of that limited funding? So basically what I did is I brought the Manley barrier data into desktop. Again, route and mileposts were collected, so I was able to tie it in with our LRS. We also have AADT and speed limit, which also has route and mileposts. So it was a real simple analysis using the overlay route events tool. I was able to assign the speed limit and the AADT for each section of roadway for each specific barrier. So you can see there in the photo, that's an example. That's in the rural part of the state in southern Utah. That is one of those older Texas turndown designs. It has the wood posts and it's a W-beam rail. That particular section of roadway is 65 miles an hour on that 2-lane road. And we've got an AADT of 1,300. So then what the traffic and safety folks did is they came up with a risk score. So there's a certain set of barrier type there you can see on the table on the far left. The more up-to-date, more recent designs had a lower risk score. The Texas turndown and the Jersey barriers had a higher risk score. They also assigned a risk score based on speed limit. As you can see, they're increasing. We do like to drive fast in Utah, so we've got some 80-mile-an-hour sections on our rural interstates. And then again, a risk score based on AADT. And so essentially just assigned each of those 3 scores and multiplied them out. So again, going back to that same Texas turndown in rural Utah, you can see that's a high risk barrier, so it received a 9. It's also a high speed limit, received a 9 on that, but it's a very low AADT, so it received a 2 for a total score of 162. Just to provide some context on how some of the other barrier in the state would score, we'll go back and look at that Jersey barrier that I pulled up in the web map example. This is an urban interstate right near downtown Salt Lake. This actually goes between the airport, or international airport, and downtown. We get a lot of truck traffic. I-80 comes in from Nevada. This is, I think, the nickname Crossroads of the West. So we've got a lot of truck traffic, a lot of passenger vehicles. So again, looking at this, it's one of our outdated barrier types, so it receives a 9. The speed limit here is 70, so that receives a 10. And then the AADT, obviously much higher, 71,000, that's a 9 as well. So again, you can kind of see how we'd start to rank these different barriers. This is an older, outdated design in rural Utah, but much lower exposure risk simply because there aren't as many people driving past it. And in here with the urban interstate, we've got a high risk barrier with a high speed limit and a lot of vehicles going past it. So that kind of gives you a comparison of how that would start to shake out once we did assign those different scores. So again, kind of what did we do with all of these pieces? How did we start to communicate this information? Our projects are done at a region level here in Utah, and so the big thing was getting this information to the regions and helping them understand what the barrier picture looked like and how they could best start to leverage some of those funds. Another thing that this allowed us to do was tie it in with our 3-year plan of upcoming planned projects. And we could say, hey, if we're already going to be working out on this particular section of roadway, let's take a look. And if there's some outdated barrier in that area, maybe we hadn't been intending to work on that initially, but if we can tie that in at the front end, maybe that's some low-hanging fruit where we can get to some outdated barrier, roll that into the project cost, and just for an incremental more amount of money, start to chip away at some of that outdated design. So we also wanted to show sort of the spatial distribution within each region, get them to understand that, and then look for clusters of high priority barrier that we could, address in one fell swoop and kind of look for economies of scale. The other GIS tool that I put together for traffic and safety, just as a communication tool, UDOT has really embraced story maps as a way to communicate some of this information. Our senior leadership has used them during the legislative sessions. We use it as part of our project prioritization with the Statewide Transportation Commission. So this is a fairly well-known way to communicate some of this information. The department definitely likes story maps. So I won't show you this whole thing. It's essentially the presentation I've been giving you guys today, but in story map format. So again, it just kind of looks at current and future needs. The idea here was to make it, a dynamic, interactive, visually appealing way to, present some of this kind of dense engineer speak stuff. So we just kind of tried to walk through, put together some of these bullet points. Like I said, it's essentially the same stuff I've been talking to you guys about today. Obviously, pictures are always good to get people's attention. Crash pictures with barriers keeps everybody awake, right? And then we also broke it out. Like I said, Utah is divided into 4 different regions, and so we tried to make some of this information region specific as well, so they could use it Again, this shows high risk barrier. If the service loads, there we go. Again, that's the Jersey barrier, and the W-beam, which is the Texas turndown, shows some graphs for replacement of each type, shows total count. And so again, this is something that can easily be updated whenever we do a new Manly run. If there's a large project that replaces a good chunk of barrier, we can come in and update it as well. So again, that was just kind of one of the tools we put together to start to communicate some of these findings, because obviously that's the key component in terms of receiving additional funding, is communicate the need, show people why this matters. And this, I think, provided a fairly powerful way to communicate some of that information to a maybe not necessarily a technical audience. So again, just to recap, GIS was used for the Manly LiDAR collection. That gave us kind of that initial snapshot idea of the assets that we have in the state. It showed the spatial location, gave us the attributes of barrier type, and then also collected that road view explorer imagery. That was used in that web map that I provided the traffic and safety personnel to do that visual inspection of the Jersey barrier to give us a little bit more granular understanding of the barrier types, and then did the desktop analysis to use our LRS using the overlay route events tool to assign speed limit and AEDT to each barrier type so that we could come in and start to prioritize based on risk and exposure. And then also that simple story map that was designed to help start to communicate these findings at a region level and to senior leadership, just because that's going to be how we start to get additional funding for this effort. So again, the presentation today showed you kind of the importance of barrier and guardrail assets in Utah, showed you how we went around identifying problematic barrier designs and started to understand the spatial distribution and start to quantify in terms of dollar value of this stuff, given our current funding picture, what our anticipated trajectory and timeline was for, finally replacing it, and start to understand how we could more efficiently, leverage the limited funding that we had, maybe tie it in with existing upcoming projects or identify hotspot areas, and start to try to chip away at that a little bit sooner and accelerate that timeline for getting the substandard barrier design off of our roadways. And again, GIS was instrumental in kind of understanding and quantifying this picture, as well as presenting the findings at the end of the day. So that's it. I guess, Penelope, are we taking questions now or at the very end of the webinar?
Yes, we'll certainly take some questions now. If anybody has any, feel free to type them into chat or raise your hand and I can unmute you, or any number of things. You can raise your hand by signaling the hand raising thing in the in your dashboard. Sorry, English is my first language. So I'm also going to unmute Ryan. Oh, but he seems to have disappeared. Oh well. So are there any questions for Caitlin right now? Well, I don't see any. So, here we go. Well, nope, there is one. Not so fast, Missy. How do you handle the change of management of guardrail assets?
I'm sorry, what was that?
The question is, how do you handle the change of management of guardrail assets, hits, new installs, etc.?
That's done, again, at a region level. That's generally done at a maintenance level. Traffic and safety is responsible for the allocation of those funds, but that's really handled at an individual level, which is why it was important for this project to communicate these findings out of just central traffic and safety here at central UDOT and get those out to the regions, because that's where the day-to-day replacement projects and maintenance actually happens.
Okay. Are there any other questions before we move on to the next presentation? All right. Well, we're going to try and do this. We seem to have lost the presenter, but hopefully he'll be here soon again. I'm going to go ahead and take this back to them.
Hello?
I hear them. I hear them.
Hello?
Hello.
Hey.
I'm about to introduce you.
All right, great.
So our next presentation is on environmental impact assessment, streamlining assessment, and/or streamlining with GIS. And the presentation is from Ryan Arthur of the North Carolina DOT. Ryan didn't send me a bio, so that means I get to say things like he raises cobras and loves pastrami. But I'm going to let him introduce himself. Ryan, I'm going to turn it over to you, and you can tell us a little bit about yourself and then give us your presentation, please.
All right. Give me 1 second. I'm going to show my screen, and let me know if you can see my screen.
I see someone's bicycle spandex short-covered butt.
Yep.
And now it's moving.
That's the correct one. All right.
All right.
All right.
And now you're...
Great. I'm Ryan Arthur. I've been with the DOT for 3 years now. I worked heavily on roads and highways as a business analyst and worked through that implementation. We're moving along strong now. And I'm also here with Eric Wilson from KPI, who's been helping me on a new project, which I'm going to be talking about, which is, environmental impact analysis and to help expedite project delivery at NCDOT. The caveat with this project is it's ongoing, and we'll get into the details with the presentation. So go ahead and get started here. All right, so the goals of the presentation are, I want to share the evolving story of a unique project at NCDOT and to inform you all about how GIS can be used or will be used to help expedite project delivery in the future, the near future, and emphasize how web-based GIS applications can help improve or enhance the ability for DOTs to complete some tasks. And additionally, offer some lessons learned based on this ongoing experience. So, before I start talking about the project itself, I'll give you a little bit of background about the project delivery process at NCDOT. And I'm doing that because, for me, I'm in the GIS unit, and I wasn't necessarily exposed to so many of the other things the DOT does to make projects complete and successful. So the first step in project delivery process is planning. NCDOT has a comprehensive transportation plan that's about 25 years out. And that's where our planning department works with planning organizations throughout the agency to figure out what needs they have in the future for transportation. The next phase is programming, where the needs identified in the planning stage are evaluated in a data-driven scoring process, and those projects are put into this application called Spot Online, and those projects are objectively prioritized based on different scores. So those are ranked, and the projects that make it through the ranking process are ones that get funded. After the project gets funding, it goes through the project development and environmental analysis phase, where the DOT has to adhere to NEPA and SEPA regulations. Those projects go through a lengthy analysis phase. There are many deliverables that have to be completed to ensure that the project is adhering to all those standards. Once the project goes through that phase, they come out with a design, and then we've got property acquisition based on that design, and then we have construction of that roadway. The phase that this project is focused on is the project development and environmental analysis phase. So to set the stage, NCDOT was not meeting expectations for development timeframes. Upper management wanted us to meet a goal of 3-2-1. So that's 3 years to complete your most complex projects. That's the environmental impact statement document. They wanted us to do the environmental assessment document in 2 years, and in 1 year complete the categorical exclusion. And this goal was communicated to just about everybody throughout the agency. Here you can see the breakdown of our projects, and keep in mind North Carolina has quite a lot of roadway that we maintain. We have about 1,500 STIP projects right now in this cycle of STIP. So here's the breakdown of our projects. We got your most complex EIS. That's in red is what we're aiming for. We're actually kind of okay in this aspect. For the EAs, though, we're at around 4 years on average, and they want that down to 2. For your least complex projects, we're hovering around 3 years, and they want that down to 1. An additional catalyst for the project was a specific STIP project that we did, and it was the Kinston Bypass project, and it was a little bit novel for the agency. They took a different approach than they usually do. So right there you can see the environmental features map, and you can see that the project was in close proximity to other STIP projects in the area. So what they did was they collected data on a regional level. They didn't just collect data just around that project. They collected data from other projects in the area, and they used that old data or that recent data to help inform their project. The screening there was they did a manual screening using GIS to help reduce the development time for the project. And I wanted to note that the screening was a manual process done on a desktop. The GIS data, as I said, was able to be used for several different uses throughout the project, and it was able to be used on other projects in the area. Additionally, we've had a little bit of reorganization. We had a little bit of decentralization, so we have more projects going out to divisions instead of saying central. So the divisions are getting more projects than they've ever had. And we've also had in the past 5 years, there was another manual screening tool that was developed to help determine which projects would stay at central or which projects would go to the divisions. And this was run by only one person in the environmental analysis unit, and it only went to one other person. And the output was an ArcPy tool that ran for about 41 hours on every STIP project. It buffered it against about 100 environmental layers on somebody's desktop. The output was a complex spreadsheet with hundreds of columns, and while it helped determine which projects stayed at central or which ones went to divisions, it was complicated. It took a long time to run. It didn't capture data, and so it was a catalyst that with the Kinston Bypass reorganization helped kind of get this project moving. So all those things came together. We also got a deadline. They wanted upper management wanted us environmental analysis unit and project management group to find a solution to speed up project delivery and get that into place by October 2018. So that's coming up soon. Main focus was screening projects for environmental impacts and building predictive models for some of those key data sets. So again, we had agency reorg, we had the 321 mandate, we had a deadline, and we also had some catalysts, which were the Kinston Bypass and screening tool. I'm going to hand it over to Eric, who is leading the GIS effort on our side.
Right. My role in the project is to help Ryan communicate and work together with these different subject matter experts that are involved in the environmental work and also some of the human environmental work, and then also some of the other groups within the agency itself, and coordinate those groups with the GIS unit to make sure that all the different types of screening analysis are happening effectively, and that the data that we capture for them will be able to answer the questions. I got involved in the project in a really strange way, and that's what the unorthodox approach is. Basically, the DOT had an industry day, and that was basically a meeting where they put about 100 and 120 people in a room together and said, hey, this is the project we want to do, and they broke us up into 4 separate groups, and they said, hand your resumes in to particular people in the room and have a quick 5-minute speed dating interview, and then when that's done, we'll pick the best of the folks out of there, and we'll go with that. So I'm not so sure that, that was an effective way to gather the people, but somehow a lot of us fell out as being the ones who were selected to help. And the people were divided not only into a GIS discipline, but they were involved in being divided into a number of different subject matter areas. So essentially you have people who are experts in wetlands and streams and threatened and endangered species and hydraulics. We had a catch-all category called sweeping environmental. And then we also had some of our transportation modeling folks and also doing capacity analysis. And basically what this whole menagerie of people does is they say, hey, we are all involved in project delivery on some level, and we each contribute a little bit of analysis and a little bit of data to the overall product. And so what we want to do is be able to translate our analysis results into something geospatial that can be put into a product that can be ingested by the project management team. And that includes consultant project managers and also the DOT project managers. And so what our role is, Ryan and I's role, is to basically receive a lot of that information and help them organize their data effectively to do that job. So it started out with a bunch of detective work, and this is a funny slide that Ryan put together. We basically started out, we didn't even know each other before the project started, and so we had to basically sit down and say, how are we going to do this? And basically we just started with a bunch of detective work. We didn't really even understand what project delivery meant because we're GIS guys, we're not subject matter experts, and we're not project-related consultants or design engineers or things like that. So we had to go through all that, figuring that out. And there was some documentation, and there was also uncovering of documentation that would have been helpful to know earlier. Things like that happened all over the place. And we really had to figure out just what project delivery meant and what data was out there that could support automating that effort a little bit more and reducing the time. So we developed some Visio diagrams, one of them you see here, which basically outlined from the DOT side what project delivery actually looks like. And you can see, like Ryan said earlier, you start at comprehensive transportation planning and you work your way down to the environmental documentation. And then we had to figure out where we would make improvements to that along the way. And one of the areas that we know we needed to make improvements out of all that work was in the project scoping process, which basically is where the rubber meets the road. The local organizations, the MPOs and the RPOs propose a project, and they come together with the DOT and decide actually what's going to take shape. And a lot of times, right now, the way the DOT does business is there's a lot of analysis and basically desktop work that gets done to figure out exactly what they're going to run into in the field, what actually is possible, and what actually will get built. And so what we can do as part of this project is provide a lot of efficiency there to help that scoping process take shape rapidly. And so we spent a lot of time whiteboarding just exactly what was going to be created. And so you can see here on the left, we're talking about scoping and pre-scoping, and then we kind of move that over to the right where we start looking at maybe what kind of deliverables and timeframes we're looking at. So it was a very, very organic process, I would say, from the beginning. We were discovering, we were learning, we were trying to figure out scheduling and all these different obstacles we were facing. And so we can start to explain a little bit more clearly to people what exactly was possible. And one of the ways we did that was through visualizations. And what we were able to do was show that existing way business gets done. And then we were able to show here in orange places where process improvements could occur and how those process improvements would be able to make life easier. And then in addition to process improvements, there was data access improvements. And then there was also some reporting improvements that we could make too. And one of the things you see there as an example on the left side is just using Microsoft Power BI to help explain the data better than just giving a spreadsheet. You can give them fancy interactive charts and graphs. And that really helped for people to understand that, yes, there's data out there that we can gather, and the process improvements we're going to put in place will help improve that data and help us to, in the end, see the data a little bit better. you or me.
Yeah, I can do. We're going along and we're kind of getting the bigger picture and starting to understand some things. But one thing that you realize when you're going and talking to all these different business units throughout the agency is that everybody received that message from upper management. And so you've got a lot of folks, a lot of business units that maybe aren't talking to each other that are all starting to expedite project delivery on their own. And so, Eric and I are out there talking to folks, and we're realizing, hey, we've got traffic forecasting folks that are starting to do proactive traffic forecasting and not waiting for a project manager to manually request a project or a traffic forecast. And we've got other groups doing similar things. And so we're realizing that, we're taking these pictures of the diagrams of the full process, and we're showing them, hey, this is where you are, and we're kind of bridging some gaps and getting people talking together. We're trying to unify everybody, and so that's how the project has developed into a bigger project called Project Atlas. That's how it's known now, and that stands for Advancing Transportation Through Linkages, Automation, and Screening. And so, now we're getting all the business units on board and linking everything together and trying to create like one unified process and one unified system to help everybody get through project development.
So part of that business analyst work revealed several things that were basically required for project delivery to move along faster. One is the project management folks and also the people who were doing the environmental work or the human work, they didn't really use the same data. They didn't understand where the data was. They didn't understand, what it meant to have data that was old versus new. And so there was a lot of, consternation about having the right data. So the first thing we are putting in place is a search tool, which basically allows people who are involved in project delivery, even those on the outside, to look and see, okay, which data do we use to answer the questions? So if we're going to do a categorical exclusion or we're going to be doing some field work, we have the data organized in such a way that you can say, okay, I want to do a natural resource technical report. What data do I use for that? And you can go and query the system, and then you can actually pull the data down if you want. You'll be able to visualize it, seeing, if this is the right data you're expecting, et cetera, et cetera. Next is a screening tool, which sort of builds on top of the search tool, and that takes that data, some of that data that's in what we call our data repository, and uses that to get a human and environmental screening, and essentially, show the impacts of possible impacts to a project alternative or the actual project alignment. Then finally, we're going to work at providing a project management platform, which is a sort of like a one-stop shop, some have characterized it as, where project management from both sides of the coin can come and deposit their data, update some key dates, and then also do a screening or visualize some data from other previous projects. And so then as an additional part of that business analyst effort, we had to identify that data. We had to identify points of automation and then possible areas where programmatic agreements can take place. Because in addition to having great data and performing analysis, you have to have buy-in from the agencies you're working with so that the analysis that you do is accepted. So just because you say a wetland should be there doesn't mean that the method you use to determine that wetland location or potential wetland location is acceptable to maybe the Fish or Corps of Engineers, right? So what we have to do and what we're actively doing is working with those participating agencies to show them how we're doing different types of modeling, and then having them give us a thumbs up or a thumbs down, and that would be in the form of an actual agreement that's signed between the DOT and another agency that says, yes, if you perform this type of analysis, we can then accept that as an acceptable review of a project location. And then we had to develop a schedule for all this. So what we ended up doing is taking a look at the data first. We built a repository and we populated that with the different people who were participating, and then we linked those different data sets to the deliverables that they participated in, and we were able to use this approach for new business process improvements as well. We're going to be using that as well for that. So you can see here, just in terms of where the data comes from for project delivery, it's relatively large expanse of where we get it. Everything you're looking at here is all web services, or will be produced as web services. So about 75% of the data for project delivery comes to the DOT itself, and that is data that they either house or publish. And then some other major contributors are the USGS or the local Department of Environmental Quality. And then also we have a clearinghouse that is actually tasked by the government to assist in geographic data development. And so they house a number of important layers that are used in project development as well. And then, a variety of other smaller organizations also provide data to the system.
Yeah, and so Eric had talked about, we had some ideas for applications, but, and looking at the data, we have firmer requirements kind of coming in. So we have a realization that consultants and NCDOT folks do not always use the same data for their deliverables and reports, or they don't use the same data from the same, master source. So, as Eric had mentioned, a web-based search tool is needed. At many points throughout project delivery, screening could be introduced to help planners, project managers, and consultants understand impacts. So that's the web-based screening tool. Again, as Eric had mentioned, we've got project managers and consultants have only one common gateway or interface for coordinating through the project, and that is a SharePoint repository. But that doesn't give them enough tools and enough information to really know where their project is heading, what the metrics are, what the trends are. So that's the project management platform, another web interface that we'll be creating. And then, again, there's the enterprise database, of course.
And one of the things that Brian had noted early on was that there's so many different ways that people interact with data within the agency right now. What we don't want to do as part of this project is add another place for them to go. What we want to do is consolidate the activity of the project management team down to one place where they can come in and interface with those other systems and provide data to those systems or information through data entry to simplify the process and not add another complicated step to the whole thing. So this was just a simple graphic showing like how those things kind of interact and play together. And so moving forward, we're really looking at where potential for automation can occur. So we're looking at automation in the area of data preparation. One example of that is a lot of different agencies provide data in an open data format, but it's not necessarily geospatial all the time. And so, but it is out there as a web service, and so we can ping that and then return data and then associate that with spatial data to enhance some of the early on evaluations. We have a lot of modeling going on by especially our threatened and endangered group and also in our streams world. There's a lot of data being developed there, and that automation of that data will reduce the amount of field work that's performed in extraneous areas. The goal is really not to eliminate field work at all. What the goal is to make the field work more focused and better, and so that's sort of what the modeling provides. And then an evaluation of that, those results too, and also in deployment.
So again, moving forward, Eric and I have figured out kind of a path forward using different types of technology. So we're managing tasks, we're managing the project using Trello, and we're doing that because we have so many different tasks going on. Our normal method using SharePoint to manage projects wasn't going to be sufficient. So Trello is a kind of a more agile approach to managing your project. We're also using, of course, Visio for doing diagrams. I identified Enterprise Architect, which allows us to take our BPMN models and throw them into one system along with our IT architectural models and get everything aligned. We're using Visual Studio Team Server which is the Visual Studio cloud-based code repository and code management platform, where we'll be coding in C#.NET and Python and a couple other languages. We're using CAST, which is a automated code checking software, so that all the code that we're developing is in the correct standard. We're still using SharePoint, of course, and then we're using SQL Server SDE for our data repository. And as I mentioned before, the search tool and the screening tool are only going to be running against web services. That way we've got the most up-to-date current data pointed at the correct source data, because we've learned through this project that you've got consultants, or somebody at a DOT that downloaded some stream data onto their C drive, and they have been, updating it for the past 10 years, and they haven't grabbed a fresh copy from DEQ or Fish and Wildlife or some other organization that is the true authority there. And we're also looking at kind of some existing tools out there and seeing what we can build off of. One of those is Esri's screening tool. We've got the code management with the VSTS, we've got CAST doing our code management, Trello for team management, and we've got our different workflow modeling technologies. One thing that I will go over quickly is a little demo of a prototype that we've got running, this is, I think Eric can talk about how we stumbled upon Esri's screening widget while I get set up.
Yeah, so we were just basically looking as if, has anybody ever built anything like this before that's out there in a web world? And it appears to me where there was a product produced called NEPA Assist for the EPA, and a lot of that boilerplate code, I think, or vice versa, had been involved in the development of the Esri screening tool widget. And so one night I was sitting in front of the TV, just kind of like fooling around, looking for solutions, and I came across the screening widget on somebody else's, forum feed. Took a look at it, and it seems to be what I would consider a relatively useful example of what we're actually trying to achieve. It's not necessarily what ours will look like in the end, but it does provide a good example for the screening tool as far as like what we're looking to provide. So the workflow would be that a project manager comes in from the outside and has a project assigned to him, and they're like, well, what exactly am I faced with here? What am I going to hit? And so then we provide the ability to then screen that project. And so what you see here, Ryan has a bunch of different data, and he'll explain a little bit more about that.
Yeah, so we just wanted to test out this and see the viability and see. We also analyzed it from the coding perspective, and we got our developers in looking at what can we actually customize. And so so far things are looking good as to what we can customize and enhance. So, but just as the prototype, we just threw in some a small amount of environmental data that we know that folks look at when they screen a project. And so I've got our STIP projects, our funded projects here. I've got major basins. I've got some reefs, unique wetlands, and some other data. So I've got the screening widget. It's popped out. I'm able to select on the map here. I'm going to deselect everything. I'm going to make sure that my line STIP projects are selectable, and I'm going to go and I'm going to select this one project along the coast here in North Carolina. And so I've got that selected, and what I can do is I can come down here and I can actually buffer it. We know that consultants and DOT, they don't just look at maybe just the right of way along a corridor for a project. They'll look at a much wider area. So right now I've decided I'm going to buffer by a mile. And so, I can already see, some of my impacts here, and I can hit report, and, the widget is thinking, and it's kind of calculating what my impacts are. And I can already see my impacts to Croatan National Forest, and I can see, the amount of impact here. I can see I've got impacts to major basins. And all of that is very important for, the first time that a project manager looks at a project, because we have different things that we check for. Our permits are based on amount of area impacted. So we can kind of get an idea of what permits we might need. We can get an idea of what different state agencies or federal agencies that we need to get in contact with sooner, instead of going further and further along in the project and realizing, we need to talk to, Corps of Army Engineers, or we need to talk to DEQ sooner.
Yeah, it talks about the merger process.
Yep. And what I can do here is I can get a sheet generated fairly quickly that would normally take maybe a week and some extra time and just searching for data. I can generate a sheet to take to the scoping meeting so that we can kind of kick off the project in the right way, and it outlines my impacts, what data sets are impacted, and it gives me what normally would be a lengthy process to generate the map. So this is one area that we're looking to enhance, and looking to possibly use this as our screening widget. And again, this project is in motion now. We have a deadline of October. So actively right now, we've got developers enhancing the screening tool. We've got developers working on building the search application, and we're gathering requirements right now for our management platform. So, further down the road, we'd be able to show you, all the applications.
Yep.
And so that's where we are right now.
Thank you. Thanks, Eric and Ryan. Are there any questions from the people attending the webinar for Eric and Ryan? Or any more questions for Caitlin? I'm not seeing any questions coming up yet. I just want to give people a moment to think about it. Questions?
Well, I'd be happy if anyone has any questions if anyone wants to shoot me an email or anything like that. I know other DOTs have been looking into enhancing environmental impact analysis and project development. So, I'm always there to talk offline as well. I'm always interested.
We do have a question for you. And the question is the mapping that you showed at the end of the presentation mostly programmed by you or using templates from ESRI?
That is a template from Esri.
The actual application is a template from Esri, and the data itself that's being read in, all the symbology is driven by those who provide the data.
Yep. Yeah, the idea is we want to get the folks that are doing project development and environmental analysis all using the same data that we've all agreed is the source and the best data. And so using those web services pointed at the source is the way to go there.
I think we're all working on efforts for data standardization, right? And here's another question from the same person, Linda DeMasi. Are you using mostly web feature services? If you are you using your data? If you are using your data, how are you accessing it? Through SQL, etc., SQL Server? What are you doing?
So we're using a variety of different techniques in this product. The majority of the people who participate in serving data out in the web, they use ArcGIS feature services. But there are a fair amount that also use ArcGIS mapping services. And so we are using the geometry off of those services either or. And so what we're doing is we have a Python developer who is building a backside geoprocessing service that's going to be available to the tools that we have being put in place. And he will be able to, in the application, will be able to either read the geometry coming off the feature service or read the geometry coming off of the map service in order to then take that geometry and then do acrobatics of overlaying and getting calculations and whatnot. One thing we know we cannot do is we can't use OGC mapping services with the JavaScript API. So that's one of the other reasons why we're working with Python and the geoprocessing service world to try to avoid that wherever possible, being that we want to use web mapping services and use an OGC standard. So we may have to use a couple of different libraries to get at it. That's sort of the way it's proceeding at the moment. That's still under development.
Okay, I just want to give a moment to let other people ask any questions if they have any. And currently seeing no more questions. I want to thank you, Caitlin and Ryan and Eric, for presenting today on the GIS webinar, the GOTUG webinar. And I want to say that we have another webinar coming up. Our next webinar will be on September 5th. It's going to feature HTML5 mapping capabilities and should be quite interesting. This webinar has been recorded and it will be published together with the presentation, so that's a good opportunity for me to remind you, Caitlin and Ryan and Eric, to send me your presentations as you presented them so that I can put them up for people to download. And with that, I think we conclude our 10th GOTUG webinar. Thank you very much.